Thanks, Tyler. Thanks for the introduction and a little bit of background about me. I've started working with MVC architectures like Django, and I've progressed over the years with all of these new terminologies like serverless and whatnot, right? So that brings us to today's topic on three-factor apps and a new design pattern for building apps around serverless, right? So let's dive in and see what the traditional architecture typically looks like in your application. So you have this application which contacts the API layer, which is like the MVC pattern, like the Django or the Rails application, right? So which then connects to databases. And then the API layer also communicates with other microservices, like in the example of a food delivery or an e-commerce scenario, you'll have the payment services and tracking services, right? So you have a bunch of these services connected, and there is this huge monolith in between, which is the API layer, where the app is served by Django or Rails. And then you also have the API layer talking to the database and a bunch of other services, right? So if you think about going serverless from this model, what does it take to go serverless from this whole MVC architecture, right? So the naive way of putting it out is, do you host the entire app on Lambda? What does it take and will this work, right? So the whole app is on Lambda, thinking of serverless as just your managed compute instance, right? So just resource management is what you're trying to solve for. But obviously this comes with its own problems. The monolith complexity still exists. You're just not solving it by just putting it behind like a serverless platform. The MVC pattern is bound to be resource consumption heavy pattern. So the complexities are not really hidden when you're just moving it to a single app on a Lambda function, right? So what are the different problems to solve? If you look at the problems from the traditional architecture point of view, for an MVC app, the scalability is the biggest bottleneck, right? And scalability depends on like the weakest link in the chain. You have like multiple components in your application, different services connected to your app, and there's a database, and assuming that your MVC app is now on serverless, the single application, now the boot times will be very high, and the architecture is generally going to consume a lot of resources, and you're just basically just hiding the complexities behind and not really solving the fundamental problem. So scale is definitely a big problem. And is your app resilient? So what happens if a VM crashes? And what is the recovery logic? And there's a verbose error handling that needs to be written, and there's a lot of code to be written to handle this, right? So is the app resilient? And that's the second problem to solve, right? And the third problem is the development velocity. So typically with these kind of frameworks like Django or Rails, it's easy to just prototype quickly, build fast, but then as you scale and as you start adding more features, it's difficult to iterate and manage at scale, right? So that's a bottleneck, and we'll come back to how that can be solved. A solution would be to move towards asynchronous pattern. To solve these problems, basically the community has designed patterns to make the app execution model via the asynchronous model, right? The problems in traditional architecture typically happens because you have these components interconnected and tightly coupled, right? There are dependencies between each component, and they tightly coupled. So you have this bottleneck because of this fundamental design. And synchronous requests generally means that resources are required just in time at that moment, and hence the bottleneck is not going to be easily solved, right? So by moving to async, you can leverage event queues and break the assumption that the app is generally synchronous in nature. So the fundamental idea is to just break the assumption that your app is synchronous. But for developers, it's very easy to have a mental model of synchronous events, but there's a hard time modeling async events, right? So that's where we bring in 3factor app. 3factor app is a modern app architecture for building full stack applications, and there are like 3 factors to it, right? So the first one would be real-time GraphQL. We look at why GraphQL and what the choice behind this in a minute, but there's mutation in subscription logic involved for why GraphQL will make sense. So with GraphQL, you manipulate state and subscriptions, and you need a reliable eventing system, which can spawn events and handle retries and logic, right? Business logic of your application is basically triggered via events. So you need a reliable eventing system to initiate business logic. And the third factor is async serverless. This is primarily for like infinite scale, having to not worry about operations, right? And manage the servers. So you have functions which are cohesive units, which are designed to perform some operations at a time, and they'll need to have properties to handle the events, right? So that's where serverless will come into picture. Look at the architecture now. This is the new 3-factor architecture where you have the application, you have the real-time GraphQL API connected, and then you have the whole event system attached to it. The heavy lifting of custom logic has now been shifted from the microservices to an event system, which takes care of reliability and guarantees the delivery of events, right? So why move to this? You now have a simple API layer for creating events. Everything is now persisted on state, the database source for which API contacts, and you have a flexible eventing system that handles retry logic, timeouts, and so on. And you have all of these serverless functions, which are functional units of your business logic. For example, sending an email is like a functional unit, then which goes on to be deployed on serverless functions, right? So let's revisit the problems again now. With serverless event-driven architecture, you are ensuring the problem of scalability being solved. No ops to manage, no VMs to manage. Just write code and deploy, and then scale for free, unlimited, right? Resilient. Now, incoming requests that comes into your application is event-driven. Events going to trigger a series of functions to execute. Events are also persisted. So if something happens to your system, if the restart happens, we can start off from where we left off and retry on failure, right? So that's for resilience. And finally, for developer velocity, the API layer is now simpler. You can now build faster and iterate faster. With real-time GraphQL, you also have the asynchronous handling of events on the front end. You have GraphQL subscriptions, which makes it easy to get notified for the events state, right? And finally, as a summary, I can just say that 3-factor app is easy to think. There's a mental model. It's easy to design the architecture itself from scratch. So if you have like a greenfield app that you want to try out, do try it out with the 3-factor app architecture, right? So yeah, that's mostly it from my side. Thank you.